Hello student, today we'll discuss on the topic of clock SR. In the previous lecture we are discussing about the 1-bit memory cell. See now these are the diagram, okay, G1, G2, G3, G4, like these are the 4 NAND gate we are using, right? And here we are making the provision of entering the inputs, okay, so S for set and R for reset. So the memory cell with provision for entering data here we are making, and if you observe, if the S equal to 0, R equal to 0, if 0 both 0, so due to this NAND gate, okay, so both output of G3 and G4 is 1, means if one of the inputs of the NAND gate is 1, then output depends upon the other input. If one of the inputs of NAND gate is 1, in that time output depends upon the other one. Means does mean that if you remove this circuit, so it acts as your previous circuit, means 1-bit memory cell. Okay, so that's why we can call as, if S equal to 0, R equal to 0, the circuit exactly same as the previous circuit. Now we consider S equal to 1 and R equal to 0. S equal to 1 and R equal to 0, what will be happen? So if it is 1, it is 0. If it is 0, then obvious it is 1. If it is 0, then we can consider it is 1. Again this 1, okay, one terminal of G2 is 1, and here it is 1, means it is output is 0. So here is 0, here is 1, okay, so 0 means again it is 1, this one is applied here, both 1, again both 1, in that time it is output is 0, right? And this is applied here. Now see this 0, okay, and here is 0, then the inverter it is 1, means it is 1 and it is 0, this condition will be fulfilled, and value of Q is equal to 1, does mean that the flip-flop is in set condition. Flip-flop is in set condition. Now observe, S equal to 0 and R equal to 1, what will be happen? S equal to 0 and R equal to 1. So S equal to 0 means it is 1, R means it is 0, right? So if one of the input is 0, in that case it is output is 1. This one is applied here, okay, here is 1, okay, so both 1, it is 0, then is applied, right? So both condition will be fulfilled, 0 and 1. So whenever S equal to 0, R equal to 1, in that time Q is equal to 0 and Q bar is equal to 1. It is called as reset condition. It is called as reset condition. If the input condition are changed from S1, S equal to 1, R equal to 0 to S equal to R equal to 0, means both are 0, or from S equal to 0 to R is equal to 1 to S and R equal to 0, the output remains unaltered. These are too much important. Unaltered means what is the previous output? I will elaborate again. If S equal to R equal to 1, both the output of Q and Q bar will try to become 1, which is not allowed. Therefore, this input condition is prohibited. This input condition is prohibited, okay, and its meaning is whenever we are connecting 1 0 2 0 0, and that time means what are the previous output that will be displayed. In 0 1 output is 0, so it will be displayed as a 0. In 1 0 output is Q is equal to 1, so output will be displayed as a 1. Now see what will be happen if clock SR. Clock SR, it is often required to set or reset the memory cell. Often required to set or reset the memory cell in synchronism with train of pulses known as clock. Such a circuit is referred to as clock set reset flip-flop. In this circuit, if clock pulse is present, means clock is equal to 1, its operation is exactly same as the above circuit. But if clock equal to 0, in that case what will be happen? G3 and G4 are prohibited, that is their output are 1. See, G3 and G4, we can see here is we applying the clock, both clock is 0, means both 0 means what? G3 and G4 both are trying to make as a 1, make as a 1. So assuming that the input do not change during the presence of the clock pulse, assuming that the input do not change during the presence of the clock pulse, we can express the operation of flip-flop in the form of truth table or the SR. Hence Sn and Rn denote the input and Qn is denoted the output during the bit time n. During the bit time, whenever the clock pulse present, that time we can denote it by small n. And Qn plus 1 it denote output after Q, after the pulse passes. That is, if you see both 0, 1, 0, 0, 1 and 1, 1. 0, 0 at that time, this Qn plus 1 means after the passing of the clock pulse. And Qn in that time both 0 means whenever it is nothing but act as whenever clock pulse applied before the clock pulse. Okay, Qn means act as previous, what is the previous outputs. 1, 0, then 1, 0, 1 is 1 and 1, 1 is prohibited, it is not valid. Right? Now see, if the present and clear input in the flip-flop of the figure, when the power is switched on, the state of circuit is uncertain. It may become to set is equal to 1 or reset state. In many applications, it is desired to initially set or reset the flip-flop. That is, the initial state of flip-flop is to be assigned. This is accomplished by using the direct or asynchronous input flip-flop or preset flip-flop. So preset or clear inputs, these input may be applied at any time between the clock pulses and are not in synchronization with the clock. So if PR and CR is equal to 1, the circuit is again according to or accordance with the truth table of SR. But if preset PR and CR is equal to 1, in that case Q equal to 1 and Q bar is equal to 0. Q bar equal to 0. Here Q bar is equal to 0. Q is 1, that's why set. If PR is 1, CR is equal to 0, then you can call it a reset. You can call it a PR terminal were applied to the G1 and CR will apply to the G2. Once the state of the flip-flop is established asynchronously, the asynchronous input preset CR must be connected to logic 1 before the next clock pulse is applied. So PR and CR is equal to 0 not be used because both of gates will be tried to make as a stage uncertain stage. Okay, in the logic symbol of figure bubble are used for preset and clear, which means these are the active low, that is intended function is performed when the signal applied to PRCR is low. The operation is summarized in the tables as above. Okay, as shown in the above figure. So in this way we learning using the NAND gate SR flip-flop, clock flip-flop, as well as when we apply the preset and clear terminal. Okay, thank you.